Best Pedestrian Route is a new kind of construction walkway that really rethinks construction barriers here in Lower Manhattan. My partner Nicole Robertson and I entered a competition back in April 2007 that was sponsored by the Lower Manhattan Cultural Council and the Alliance for Downtown New York called Reconstruction, to really rethink the nature of temporary construction barriers in the midst of all of the reconstruction that's happening in Lower Manhattan. We have the World Trade Center site, we have the Fulton Street Transit Hub, as well as some smaller projects. And there really is a lot of confusion on the ground here in terms of pedestrians, in terms of tourists, in terms of people commuting to work, where the traffic patterns are really changing on a daily basis. So my partner and I decided as our entry what we would do is start by mapping all of the construction sites down here within several block radius and look for a kind of opportunity to do some kind of insertion that might make sense of this. Once the mapping was undertaken, we really became very interested in the Jersey barriers of all things that typically symbolize the edge of a construction site. And what's interesting about these Jersey barriers is they're painted with orange stripes at something like 28 degrees. And we thought it would be a really fantastic opportunity for Best Pedestrian Route to try to spatialize these things. One of the outcomes or effects of that spatialization, if you will, is that our structure would be inherently leaning. And we thought that the lean would really make sense in terms of the instability and the temporary nature of these construction sites. One of the things that we had to build into Best Pedestrian Route was a real sort of flexibility and functionality. It was originally conceived as a modular system, but that modular system had to be able to anticipate curveballs from sites. So for instance, there could be a slope in the sidewalk, there could be a fire hydrant, there could be a payphone, there could be a stop sign. All of these had to be quickly built into the model. And so we launched into a model building campaign and a lot of design research, this being a very early model. And we used the Fab Lab, the laser cutters specifically in the Fab Lab, probably made about 5 or 7 of these in a 1 month, maybe 3-week period. And these were very quick. They were all designed on the computer in a 3D software we use called Rhinoceros, and very quickly organized so that they can be laser cut. And you can see here that this is constructed of a kind of lattice framework that ultimately gives it rigidity. This came right from a 3D digital model. And it's that same 3D digital model that we used to produce the series of scaled models that ultimately was used to do all of the final cutting for the installed pieces of Best Pedestrian Route. Once we were told we won the competition, there were a series of logistical issues that came up. The first was how we actually fabricate Best Pedestrian Route, and the second involved the time sequence of the project. Speaking to that first, it was becoming late summer, the fall was coming, and I have a lot of teaching responsibilities as well as other responsibilities at the New Jersey Institute of Technology and the School of Architecture, as well as having a series of other projects going on here. As September rolled around and it looked like the installation was going to be set for mid-November, it became very quick to realize that I had to put together an independent study of NJIT students to really help work through, again, the logistics of building and ultimately the time it takes to fabricate, to cut all of the material, which was primarily plywood, get it on site and do the installation. Once the students actually were given a little bit of direction in terms of the digital model and the task at hand, they really took the problem and ran with it. Ultimately, the independent study, I think, turned the issue of timing and installation into a really great opportunity for the work that we're doing at the School of Architecture at NJIT. The Fab Lab, which was something we created back in 2005, ends up being a very interesting way to mediate between the academic and design research concerns that I think I have as a professor, as well as the more pragmatic and professional construction-related concerns that we have here as architects. And I think Urs Gauschot, the dean, saw very quickly that there was opportunity to use the lab to help us work through this problem of figuring out how to design for fabrication Best Pedestrian Route. Once we were given a site, we actually received a curveball by the Department of Transportation in that they wanted to see a full-scale mock-up of Best Pedestrian Route built somewhere before they would allow us to install it on a city sidewalk. Fortunately, one of the spaces that we have for the Fab Lab is a very large industrial space with about 30-foot ceilings, and was the perfect venue for doing so. So once the team of 9 students was established, we quickly went into a very ambitious kind of cutting schedule where we were using the CNC router that we have. The students and I worked fairly full days, especially Friday, Saturday, and Sunday, to build about 3 bays. And you see here, this would constitute a bay of the structure. And the mock-up ended up being about 16 feet tall by 16 feet wide, and had at its most extreme an 11-foot cantilever, but it stood. These kinds of opportunities don't typically come up in architecture school, this ability for the students to really grasp on a real-world problem and use the cutting-edge technology in the Fab Lab to work it through and ultimately install it. I think what we've seen in the last 5 years is the next generation or next wave of these kinds of technologies in terms of the computer numerically controlled hardware that we have. No longer is this conventional paradigm of the architect as the person who makes the drawings and hands them off to someone else to interpret and build our work necessary. We now can develop our work as fully developed virtual models on the computer screen in 3D, and feed those models via direct digital translation to the various Fab Lab hardware that we have. This means that we can better test our intentions, we can better simulate our work, we can build small-scale models to test form, and we ultimately are now getting into the fabrication of full-scale parts or components for building assembly, which is what you see in Best Pedestrian Route.